Hi. Now, in this example on significance testing, you might have seen it already because there's two versions of working this type of thing out. What I'm going to show you this time though is how we can work it out by using a critical value method. If you'd like to look at my other method of doing this, then just click on this link up here and it should take you back to that video. Okay, so I'll just give you a moment just to read this if you haven't tried it already. Come back when ready and I'll run through the work solution with you. Okay, welcome back if you had a go. So what we've got here then is that Mrs. George claims that 45% of voters would vote for her. And in an opinion poll of 20 randomly selected voters, it was found that 5 would vote for her. And what we've got to do is test at the 5% level of significance whether or not the opinion poll provides evidence to support Mrs. George's claim. So, as usual, with questions like this, what we need to do is to define a random variable. So we're going to say let x be that random variable. So we'll just put RV for short, and it's going to represent the number of votes for Mrs. George. And I'll just keep that short. Better give her a capital there for Mrs. George, Mrs. G. Okay, and the distribution that our random variable x follows is going to be a binomial model. Okay, we've got a finite number of trials, 20, and we've got two outcomes that someone will vote or not vote. And assuming events are independent, probability remains constant, then we're going to call that probability that someone votes for Mrs. George P. And under the null hypothesis, that probability is 45%, or as a decimal 0.45. Now we've seen then that we've got an opinion poll of 20 randomly selected people. And let's just do this with a number line. That's going to range from no people voting up to 20 people voting. And the expected value, the mean, is going to be 0.45 of 20, 45% of 20, which is 9. 9 people are expected to vote for Mrs. George. And we'll just put that there. But it's not always going to be 9, it's going to vary a bit, okay? But we've seen that only 5 have voted for her, 5 being less than 9. So that would seem to suggest the alternative hypothesis, that is that proportion is less than 45% or less than 0.45. And we're basing this on the fact that we've observed 5 people voting for her. And we're testing at the 5% level, so we'll set up alpha as being 5% or as a decimal 0.05. Now to do this by using the critical value method, what we're going to do is set up some value which we'll call R, that critical value. Let's just mark it in at a point down here where if we work out the probability of being less than this value based on the null hypothesis, and if this value turns out to be less than 5%, then we reject the null hypothesis. If not, we accept the null hypothesis. So this region up here is going to be accept the null hypothesis. This one is going to be reject the null hypothesis. So we've got to find out this value of R. In other words, what we're saying here is that we reject the null hypothesis if the probability that our random variable x is less than or equal to this critical value R, given that the null hypothesis is true, in other words, P equals 0.45, if this probability turns out to be less than or equal to the 5% level, 0.05. And to work out this critical value, we can look in tables. Okay, so from tables, the type of tables that we're going to work with are the cumulative distribution tables for the binomial distribution. And I've got an extract here where what we look under is our p-value being 0.45, n is 20, and we look at our observed value and we look down this column and we're looking for a value of r that gets as close as we can to the 5% here. And you can see that in these tables it's going to be 4. 5 is just slightly more than our 0.05. So from tables we see that the critical value, okay, critical value, which we're calling R, equals 4. Alright. Now, how does that place our observed value, 5? If this critical value is 4, 5 is to the right of it. It's in the acceptable region. So basically, we can say that therefore, since our observed value x is greater than r, or you could say that 5 is greater than our critical value 4, then we do not, let's put therefore, do not reject the null hypothesis. Okay? In other words, our value is not significant. And we've got to write a conclusion that goes something like this, that therefore there's evidence, okay, to suggest, let's just write that in, okay, to suggest that Mrs. George's, okay, a bit of a pain writing this in, but we ought to do it anyway, that Mrs. George's claim is correct. Alright, so this is the alternative way of doing this type of problem, by working out our critical value R. As I said earlier, there is another way. Just click on this link up here and you should find another video giving you another way of doing this. Alright?